initially we have to take a DC source. So DC voltage, let's say keeping its voltage as 10 for simplicity, one resistor and one capacitor. So these are the same values as we have already tried in the offline multisim. And now let's build the circuit. So after building the circuit, the circuit is built now. We have to connect a ground on the negative side, and we have to connect a voltage probe uh, at the capacitor, right? Now this is very simple. Now just what we have to do, we have to see it in grapher. This grapher is just like the oscilloscope. So as oscilloscope shows us the graph, this grapher tool will show us the graph of this voltage. So let's come to grapher and let's run it. So we are getting the value of voltage. Now let's change the time. Let's say minimum time is 0 and maximum time that we want to see is suppose 0.1 or 0.01. But we are not going to see any exponential curve of charging over here. So the solution is very simple. Let's change the values. With these values, what will be time constant, by the way? Can anyone tell? With these values, what will be the time constant tau? Okay, so let's connect a switch. Thanks, Muni, for telling us about the switch. So of course we need a switch. So we don't know where switch is placed. Just we will write SPDT, single pole double throw. Okay, and we have to connect in a way that this common point should be connected towards the circuit. Okay, so battery, ground, and this common point with this. Okay, so is it okay now? And tau is 1 millisecond. So 5 tau will be 5 milliseconds. It means this will full charge in 5 milliseconds. Now let's try to run it. So initially switch is at lower level. So capacitor will not be charged. As we will move it towards above position, this will charge. But the simulation is so fast that we are not going to capture this charging process. So we will not be able to capture it. So let's try to run it. Sorry for the interruption. So the solution is that we have to actually change the time. Now let's say we are starting from 0 and we want to see this till let's say 100 milliseconds, and this is 0. So here the capacitor is not charged. The voltage is at 0. Let's say 200 milliseconds is still not charged. Let's say 300 not charged. 400, 500 milliseconds. Now at this time the capacitor is charged. So the capacitor, as we moved the switch at this instant, so capacitor has charged from this point to this point. So let's keep minimum time 400 milliseconds. Now this is the curve of charging. If still we want to zoom it more, So let's put the lower limit 430, upper limit 440. This is just like this. Now see, this is the charging curve. And actually, this is set by these timings. Other way is to make the values so large so that we have an exponential curve of a larger time. So let's say we are keeping its value as 100 microfarad and this as 10 kilo ohm. Now the time will be tau will be 1 second and this will full charge in 5 seconds. So you can observe the voltage over here as well. Let's start the simulation. So see, the capacitor is slowly and gradually charged, and the same thing we can see from the grapher like this. So let's say 0 and let's again run the simulation. So it will full charge in 5 seconds. So it's necessary to run it for at least 5 seconds. So after 5 seconds, this will become fully charged and this is visible from these values as well as we will observe this from this grapher. So this grapher is just like the oscilloscope. Okay, so let's come to the grapher. Now this is almost fully charged. Let's come to grapher. Let's start from minimum time 0 and maximum time, let's say 6. And this is the charging curve. At this instant, we changed the switch position. So capacitor started charging and till over here, this is almost fully charged. So I hope uh, this is clear now.